We started the new bullet project several years ago, and it turned out to be a whole lot more challenging than we ever thought it would be. During the course of this thing, we ran into several things where we thought we had it and then we didn't.
We had a bullet that was done. It was ready to go.
We were getting ready to launch it. We were getting material ready for marketing.
And then we started doing the last of our Doppler radar testing to look at, okay, what's the BC of this thing 800 to 1,000 yards downrange?
What you can learn from Doppler is incredible. It gives you a complete flight path and all the characteristics that goes along with a projectile in flight.
We were able to dig into the drag curves that the radar gives you and find out very, very detailed that, hey, the drag of this projectile is changing rapidly at high velocities. It shouldn't be doing that.
We discovered that there was a portion of the bullet that was changing shape in flight. That's what was causing the issue with the dropping BCs.
We pretty much came to rather quickly that the tips are melting. They have to be melting.
With the current polymers, the tips were deforming and melting in flight, and that increases the meat-plat diameter, the point of the bullet. When you do that, the ballistic coefficient drops, the aerodynamic drag increases.
Everybody's bullets are doing this. It's not just any one brand of bullet, it's across the board.
And that was the light bulb that clicked on. We can see it now. We know aerodynamics heating there. Something's changing, gotta be the tip. How do we solve it?
This led us then into the study of where's the material and what kind of material can we get that will allow us to fix this problem.
We dove into the material properties of plastics. What's their melt temp? What are they at room temperature? What type of heat transfer characteristics do they have? And we arrived at a material that can handle elevated temperatures for longer periods of time.
It's a material with 2.5 to 3 times the melting point temperature of the currently used materials. And it's a molded plastic part. These you can get exactly the same point on a bullet every single time, every single bullet, and every single lot of bullets that you make.
When we made our initial discoveries and we started looking at what the implications of this would be on the industry, it makes you sit back and kind of smile because it's going to be huge.
This solved a problem that none of us ever really fully realized existed before.
We definitely surpassed our original goals with this project. The discoveries that we made and the information that we learned, it's allowed us to build the best bullets that we've ever built.